Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I want to discuss about the problem solving on slope and deflections. So in this solid mechanics and material subject, in the previous sessions, we have discussed about slope and deflection theory, and also we have derived some equations for different beams. What is the equation for slope and what is the equation for deflections we have derived. So whatever we have derived those equations we have to apply for problems. So in this session we will learn how to solve the problems and how to apply the formulas for this given. So at the end of the course the student should be able to demonstrate the slope and deflection of various beams. So already they have learned the theory, and after completion of this problem solving also they can they be able to demonstrate slope and deflections of various beams. So the beams already various types of beams are there. For each and every beam they can calculate the slope and deflection. So why? Because already they have learned, the students have learned slope and deflection theory part and the theorems. So for derivation of slope equation and deflection equation for various beams. But in this problem, the given problem, so they have to analyze which type of beam given and how to apply the formulas for this given problem. So the first problem is simply supported beam. The type of beam is here simply supported beam, clearly mentioned. Of span 3 meters is subjected to the length is 3 meters. The length is subjected to a center load of 10 kilonewtons. Find the maximum slope and deflection of the beam. So take I is 12 into 10 to the power of 10 to the power of 6 mm to the power of 4. So the E is Young's modulus 200 gigapascal. So for this given beam, need to calculate the slope and deflection of the beam. The given data, first you have to write the given data. The span L, so much given 3 meters. 3 into 10 to convert into mm, 10 cube mm. So the given beam is simply supported beam. Already you know the simply supported beam is supported with two ends, RA and RB, and the load is acting at its mid span. So the length also given here. Okay. So the center load is 10 kilonewtons. The given W 10 kilonewtons. So 10 to the power of 10 into 10 to the power, convert into newtons. So multiply with 10 cube. So then moment of inertia I, the given 12 into 10 to the power of 6 mm to the power of 4. And then modulus of velocity 200 gigapascal. So 200 into 10 cube Newton per mm square. So the given data have to apply for slope and deflection calculation. So what he has given? Span, length of the beam, so that is 3 meters, and then W 10 kilonewtons, and moment of inertia and modulus of velocity given. Now see, already we have derived this equation. The maximum slope of the beam at A is WL square by 16 EI. At A point, that is the slope. Suppose it bends like this. So what is the slope? So what is the slope at a B section? At a B point? So WL square by 16 EI. So W is directly applied. This substitute those given values. W is 10 into 10 cube multiply with 3 into 10 cube whole square and 16 into EA. The E is modulus of velocity and I also given. So those values substitute, you will get the slope in terms of radians. So how much that twisted that angle, that is slope angle. So deviated with the original beam. Similarly, the deflection, how much deflected? So what is the deflection length? Suppose the beam is A and B point. The beam is deflected like this. So that is the Y value. How much deflected? Here, so how much? Theta A and theta B. So this is slope and this one is deflection. Already we have learned. Once again recall those theories and apply here. And the maximum deflection of the beam. So the deflection is WL cube by 48 EA. So W is given 10 into 10 cube. So that is 10, W is 10 kilonewtons. Here, convert into newtons. So that's why here substituted 10 into 10 cube. Multiply with L. L also in meters. Meters or mm. Meters. Convert into mm. So 3 into 3 meters. Convert into mm. So 48 into EA. So the maximum deflection of the beam will get 2.3 mm. Next, problem 2. A wooden beam for 140 mm wide and 240 mm deep. So 140 wide and 240. The wooden beam. So not has a span of 4 meters. The length of the beam is L is 4 meters. So determine the load that can be placed at its center. So at its center, cause the beam a deflection of 10 mm. So in this previous problem, not given the deflection, load given. For the load, so how much deflected? So we need to calculate. In the previous problem already we calculated. But in this, so which load that can be placed at its center to cause the beam a deflection of 10 mm. So suppose it's deflected like this. The beam is deflected like this. So the deflection is 10 mm. The depth is 10 mm deflected. So what is the load? They take E as 6 gigapascal. E also given. In previous problem also in the E given, that is 200 gigapascal, but in this 6 gigapascal is given. Convert into Newton per mm square. See the given data. For any problem, first of all, you should write the given data. The B is 140, D is 240, the B 140. This is depth 240. The span 4 meters. The central deflection, that is 10 mm. So the modulus of velocity, that is 6 gigapascal. They given in gigapascal, so 6 into 10 cube Newton per mm square. So now calculate moment of inertia. Moment of inertia not given. The moment of inertia for rectangular section BD cube by 12. For rectangular section BD cube. B and D. So depth already given here, the width also 140 into 240 cube by 12, you will get I. And deflection of the beam at its center, that is YC. So what is the deflection formula for a simply supported beam? For simply supported beam, the deflection is WL cube by 48 into EA. But in this, we don't know the W. You need to calculate W here. Clear? So deflection you know. So here only one unknown. So substitute here, deflection given at deflection 10, and then load you don't know. L also substitute, 4 meters convert into mm, and E the given 6 gigapascal convert into Newton per mm square, and I Newton per mm square. Clear? So W finally will get 7.25 kilonewtons. So simplify this number, this equation, you will get 7.25 kilonewtons. So like this, need to calculate the load whenever if you know the deflection. So it does not ask any slope value. If he asks slope also, you can calculate slope by using these values. Already you know the W. Clear? So already previous problem. In previous problem, the slope also we have calculated here. This one also simply supported beam. So what is the slope? WL square by 16 EA. So if you want to calculate WL square by 16 EA, so substitute here 16 into E, WL square, W already calculate, substitute this value. So next problem, the problem number 3, it's simply supported beam. This type of beam also given, simply supported. AB of span 5 meters is carrying a point load 30 kilonewtons at a distance 3.75 meters from the left hand. So here, suppose you draw this diagram, simply supported here. A and B, RA and RB. The supported beam is, the length is 5 meters. The point load, but in previous case exactly at its center, but in this not given, the 30 kilonewtons acting from its left hand, 3.75 meters from the left hand A. Calculate the slopes at A and B. What is the slope and what is the slope theta A and theta B, and also deflection under the load. So here two slopes at A and B, and deflections also asked here. So take EI, directly given the EI is equal to 26 into 10 to the power of 12 Newton per mm square. So the given values are 5 meters convert into mm, the load 30 kilonewtons convert into newtons, the point load, the given load is point load. So the distance between the point load and the left hand A, 3.75 meters It's already I have shown in this diagram the 3.75. That say this point is C. So now the distance between point load and right hand. So 5 minus. So what is the total distance? 5. 5 minus this distance. So this one is 5 minus 3.7. So 1.25 meters. So the distance between point load and right hand from right hand is 1.25 and meters convert into mm, and the flexural rigidity. So the term is known as flexural rigidity EI, 26 into 10 to the power 12 Newton per mm square. So now substitute in the slope equation. So you know that the slope at A equation, at A point, W into B by 6 EIL into L square minus B square. So already we have derived in theory part. So theta A, W into B by 6 EIL into L square minus B square. So now substitute the W value, similarly B value. So what is the B? The B is from right hand side distance. From right hand side point, point is 1 point, total distance is 5 minus 3.5, you got 1.25. So that value you need to substitute here. 6 EA, flexural rigidity given directly. L also you know. So now L square minus B square, the L is 5 meter, the B is 1.25 into 10 cube whole square. So now the total, the angle, the slope at A point will get 0.00113 radians. Similarly, calculate slope at B. So slope at A, WB by 6EI into L into L square minus B square. But in slope at B, somewhat change the equation, need to substitute A point. You are finding at B. So that's why you need to take from left hand side distance. In this diagram, you are calculating A, need to substitute right hand side. Here you are calculating angle, the slope at this point, the distance need to take from right hand side. Clear? So that's why W into A by 6 EIL into L square minus E square. Now substitute 30 into 10 cube into A, value is 3.75 10 cube divided by 6 EA. 26 into 10 over 12 into 5 into 10. So here 5 into 10 cube is the length and A is the distance from the right hand side. 3.75 into 10 cube. So now calculate this value, the slope at B. So you got 0.0015. So here important equation, the slope at A is WB by 6 EIL into L square minus B square. The slope at B, WA by 6 EIL into L square minus A square. These two equations are important for this problem. Next, in deflection under the load. We also know that the deflection under the load, the equation at C point, the deflection is WB by 6 EIL into L square minus A square minus B square at C point. So what is the deflection at this C? Okay. Now substitute the W value and the B value, and then L square. So B already here, W 30 newtons, 30 kilonewtons converted into 30 kilonewtons converted into newtons, 30 into 10 cube, and A value 3.75 and B value is 1.25. So here 3.75, and so in this problem WAB. So need to write here WAB divided by 6 into E square, EIL into L into L square and A square and B square. Clear? The L value 15 meters converted into mm, and A value 3.75, and then the B value 1.25. So calculate, finally we got 1.69 mm. So like this, need to calculate the slope and the deflection under the load for simply supported beam. So one more problem we'll see here. Slope at the left support and deflection under the load, and maximum deflection of a simply supported beam of length 5 meters, which is carrying a point load of, here point load given 5 kilonewtons at a distance of 3 meters from the left hand side, and take E and I separately given here, 10 to the power of 8, not given as a previous problem, flexural rigidity. I and E is 2 into 10 to the power of 5 Newton per mm. So the given length is 5 meters, 5000 mm. The point load 5 kilonewton converted into newtons, 5000 newtons. The distance between point and load and the left hand given 3 meters, and B is 5 minus 3. So same as previous problem, but values are different here. A and B, C. So the length is 5 meter. The point load W is 5 kg. So the distance between the point load and left hand, so left side and A, and A, and this value is B. So the B is L minus A, the total length is 5, 5 minus 3, we will get here 2000 mm. So now the place slope equation and deflection. E already you know the moment of inertia given. Let's slope at the support A, theta A. So deflection under the load, Y maximum is maximum deflection, calculate. So using equation, theta A is equal to so minus WAB by 6 EI into L. So why? Because we are using negative sign, means that angle made by the tangent at A is anti-clockwise. So that used here negative sign. So W into AB by 6 EI into L plus A plus 2B. So deflection under the load is given by WA square B square by 3 into EIL. The angle, the slope is minus WAB by 6EI into L into A plus 2B. Means here W is substitute 5000, 5 kilonewton converted into newtons, and A value, I think A is 3 meters converted into mm, and B is 2 meter. So A plus 2B. So finally, this value will get in radians, 0.0035 radians. So negative sign means that the angle made by the tangent A is anti-clockwise. Now deflection under the load, WA square into B square by 3EIL. So here W 5000, A square, B square divided by the A value is 3 meters converted into mm and substitute in this equation, and B also substitute, and E value and I value, that is proximal rigidity, separately given, and substitute in this equation, you will get deflection 0.6 mm. So now he has asked maximum deflection. So slope at the left support is completed and deflection under the load completed, and maximum deflection of a simply supported beam. So the maximum deflection is under the load, the equation need to use. What is the equation here? The equation W into B by 9 root 3 EA into L D square plus 2AB to the power of 3 by 2. So the maximum, so once again here I will write, is W into B divided by 9 root 3 EI into L A square plus 2AB to the power of 3 by 2. So in this, you know W, B, W also value also you know, and B also you know the distance from its right hand side, and A is the distance from the left side, the load acting distance A and B. Substitute those values in this equation, and finally you will get the maximum deflection 0.617. So calculate. So in normal deflection is 0.6 mm. The deflection under the load, the equation is W A square B square by 3I into L. But the maximum, while you are calculating the deflection under the load at which occurred the deflection, so the maximum deflection will be occurred 0.6173 mm. So like this, need to calculate the slope and deflection for various beams. Here in today's session we have discussed the simply supported beam slope and deflection calculation. So these are the references I have taken. Ramamurthy, title of the book is Strength of Materials, and publishers are Danpati Rai Publishing Company. And one more author, R.K. Bansal, title of the book is Strength of Materials. And R.S. Gurmi and Gupta, this title also Strength of Materials, and publishers are Chand and Co. So take any one reference for further more clarification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.